Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on the my pad-80 project. And I have to say, it's a case of 2 steps forward and 1 step back. I'll just get you down onto the actual project, and you can have a quick look what I've done, what I've been playing at. There we go. As you can see, basically what I've done is I wasn't happy with the finish I got on the top of this. I could still see marks from the belt sander and gouges actually in the timber. And I know I say I wanted to leave it rustic looking, but it was just that little bit too rustic looking for me. So I took the control back out, I took the buttons out. What I did, I thought at this point it's good opportunity. Actually, I mixed some epoxy up with some sawdust, and I filled in where I put the mounts for the actual joystick there that poke through. Basically, just screws, put countersunk and push through, and now I've epoxied over the tops of them, so those are rock solid now. They can't move at all. And I put a bit of wood dust in just to give it a bit of a better colour to the wood. I mean, they're pretty obvious, but I don't mind that. Like I said, they're nice and flush and flat now. Once I took the buttons and everything out, and with it all stripped down, I just went over it with a belt sander again and got it nice and flat. But you could still see, because the belt sander's got quite an aggressive grit belt on it, you could still see a lot of the marks from the sanding marks. So I went in with some 60 grit, just on a normal orbital sander. Did it with some 60 grit, went up to some 80 grit, and then 120 grit, hand sanded it. And then basically I've just put a simple furniture wax polish straight onto the bare wood, and I'm really quite pleased with the finish on it now, to be fair. I've not done the sides, I've left the sides pretty much as they were. I just wiped them down with a little bit of the wax polish, but on the top there, like I said, all I've done is just gone over the natural wood with it's actually a natural beeswax polish. And like I said, I'm really pleased with the finish of the actual control now. It feels nice to touch. So we'll go and have a look what I've done underneath. There's been a bit of improvement underneath as well, if we can see. I put 4 nice little feet on it, so it actually sits really nicely on the desk, and actually it fits nicely on your knee as well. The buttons, they don't feel bad with it sat on your knee. So I didn't want to put, I was a bit concerned about putting feet on it, whether I ever wanted to use it on my lap, whether, they'd have the feet digging in, but no, they don't really, and it makes it really stable when it's on a desk. It can't slide around at all. It makes it feel really nice with them rubber feet on them. So I added those, and I've done a lot of the actual internal wiring, as you can see here. Basically the composite video and the left-right audio, I've wired those up. I've done it with correct colour coding as well, so we've got a yellow there, which is our composite video. We've got a black ground, and we've got a white audio wire, and the white audio wire is just wired to both left and right, because obviously the output from the little board's mono, so it just splits it off to both the same signal to the left and right channels. So I've got all that in, and then I don't know if you can see in there, they're all nice and neatly done, and I've heat shrinked over the end there, so it's nice and really is quite neat and tidy. Also, I've actually got I couldn't find the wire that came with the actual micro switch joystick, but I had a rummage through my junk box, and I found one that it was a little bit long, but I just lopped the end off it and used the 5 wires that we needed from it. So I've got that connected in. I'm not doing anything with the battery apart from, obviously, I've disconnected the actual board at the moment. We'll come to that in a bit. So obviously when the board goes back in, that'll get connected back up, but we've got the battery there wired up to its switch. Down this side I've actually made, let me see if I can zoom you in a bit so you can see this. Ooh, there we go, that's a little bit better, isn't it? Right, down in this part here, if you can see, I've actually, as well as this, if you notice, I've put a border around the inside. That's to take a base, so when this is actually finished we can actually have a base on here, so you don't actually, well, I don't see the insides. I was actually considering possibly making it out of like a clear acrylic, so you can actually see the workings inside. Depends how neat I get it all in there, to be honest. If it looks alright hodgepodge, I'll put a wooden base on it. If it looks really neat in there, I might actually make a acrylic base to fit on there. Obviously you need something that's removable so you can get access to the battery to change the battery in it. But while I was putting all that in, I made a little, basically a little stand here to actually take the PCB. Now I've got the orientation for it and everything, and it's actually going to fit on like that in there. And there's two screw holes, one there and one there, which I'm actually going to drill through into that timber there. The old plastic screws from the original case should do it if I pre-drill the holes, so I can actually screw the PCB down. It'll be secure in place there, and I think it'll be quite, it's an ideal spot for it there because it's incredibly close to the AV output, so my actual AV wires are going to be very, very, very short. Which we really want to minimise any interference, really. So, like I said, absolute optimal spot for it there. So I've got all that done, ready for that board to get mounted up inside in there. Like I said, I've already got all the wiring for the directional switches. I've not done the buttons yet. That's the next thing I need to do, is basically make a wiring loom to come off all these buttons, which will then again go probably round this way and over to the controller. It might come round this way and over to the actual control board, which will be up there. I haven't done that yet. Like I said, I was working on the little micro switch joystick there, and if you actually look, I've wrote down a legend in here. So we've got left is the brown wire, right is the red wire, up is the green wire, down is the yellow wire, and black obviously is your ground wire. So we've got all that sorted out to connect up to the controller, and that's where we take our one step back. So I've got all that ready to go, and I hate to say it, but I've blown the board up. Yeah, I've buggered the board. What happened? It's my own fault. I know exactly what I've done wrong. It's a trap we could possibly fall into, actually. What I was doing, I was buzzing out the switches here, working out which wire was, which was up, which was down, and the meter I'm using at the moment, my meter I normally use, I've been doing some work on the car. I had an issue in my car, and I'd actually taken that meter down to my car to diagnose a fault, and I'd forgotten, and I was being lazy. I didn't want to, because it was cold and wet and horrible, I didn't want to go down to the car and get it. So I just grabbed one of my other meters. Nothing wrong with that, it's a perfectly serviceable meter. The problem with this meter is it doesn't actually have a continuity buzzer on it. I mean, it does all the measurements, does all the resistance readings, everything. It just doesn't have the continuity buzzer on it. And because I was fiddling with that switch, I thought, oh, it's no problem. I have a continuity function on this little component tester that I have. I mean, this is what, basically all this is. It's one of them cheap little Chinese boards you can buy. It'll tell you, value of a resistor, value of a capacitor, things like that. Transistors, it'll analyse transistors. And I just mounted it in this nice little case to make it a little better, and just put banana plugs there for me to connect test leads to. Because that's all that's in the case, I thought it'd be handy if I had a continuity buzzer. Mainly not for working on digital electronics, more just for buzzing things out when you need to. exactly like that. You want to buzz some switches out, anything like that. So I just incorporated a little continuity buzzer in here, and all it is I mean, it's quite nice and loud. It's handy for what it is. And all it is a little buzzer connected to the 9-volt battery, which actually drives that. So it just piggybacks its power off the 9-volt battery that drives that. And that's the problem. I've been buzzed all this out and done all that. I wanted to, there were a couple of things I wanted to do with this board. I wanted to just confirm two things really. Oh, let me zoom you in on the board. There we go. I wanted to confirm two things on this board. I wanted to know whether that switch there was a normally closed or a normally open type switch, because I'd really like a reset on the back of this unit, and I was thinking about just interrupting the power for a reset. Problem is that I couldn't find in all my bits and bats any normally closed switches, normally closed momentary push switches. I could only find normally open ones, and I just started thinking, is that how have they done it on this board? Have they done what I was thinking of doing, being really cheap and cheesy, and just having that in line with the power, so when you press it, it just breaks the power. You know, it's a normally closed switch. When you press it, it opens the circuit, just breaks the power to the processor and resets it that way. Or I thought, oh, have they been a little bit clever, being that this is basically an NES on a chip, on a blob. It should have a reset line. So is that switch actually a normally open switch, and it's just pulling the reset line high or low? In which case, like I said, I've got plenty of nice switches like that, momentary, you know, push to make switches, which should work perfectly. Instead of going and getting my proper meter to test the switch on the board, I grabbed my continuity tester and I put it across the switch there, and I couldn't actually ascertain whether it's normally open or normally closed. There was something, part of the circuit, interfering with it. The only way I could actually test, I think, was actually pull the switch off. Anyway, I didn't think about it and I carried on. I thought, while I'm at it, that's the joystick there, and it's actually marked down, up, right and left, and in the centre there's two which I presume are the ground points. So when you, obviously when you pull it left, it grounds between the left and ground there. And I just wanted to check, I wonder if that ground point and that ground point are actually connected on the board, in which case it's nice and easy when I wire it up. I can just wire the one ground point, you know, and it'll automatically connect to the other one, or am I going to have to put a little wire across between the two? I was just trying to figure things out like that. And I think I probably touched one of the ups with the probes while I was doing it, and basically what's happened is this thing runs, I'm guessing at 3.3 volt. It could be even lower than that, but I'm pretty sure this will all be running at 3.3 volts. I know it has a 1.5 volt battery driving it, but that 1.5 volt battery basically drives a tiny little DC to DC converter circuit round here, which will step that up to, I presume, 3.3 volts, because most of this modern electronics like this runs on 3.3 volts, not 5 volts like the old stuff that I usually like playing with. And my continuity tester runs on a 9 volt battery. Can you see what what horrendous thing I've done wrong here? Basically, I've put 9 volts through parts of this that we're expecting to see 3.3 volts or lower than 3.3 volts, and it's dead. I mean, it is really dead. I've had the scope on it. I cannot find any activity. I can't find anything on the crystal. I can't find anything on the IC. Obviously, you can't get to the actual Nintendo on a chip because it's under that blob of resin. But you'd expect to see some activity on the pins here. It's just stuck. Nothing's working at all. Like I said, I think I've fried I've fried that. So cautionary tale, I should have been using this meter or this meter. I should have been not wanting to get caught. I should have got cold and got that back out of the car. Or like I said, I could have used that one, set on its HFE, basically as a transistor tester. It only puts a small voltage out while it's actually doing a test. It's not going to put 9 volts through your 3.3 volt circuit, which is exactly what I've done. I said all is not to lost with this, being that I've done it, and I've got this far with the rest of the project. I went on eBay and I ordered another one of these. I didn't get it from the £3 like this one either. I managed to find a UK seller with some, so it was under a tenner, and I'll have it in sometime, you know, this coming week, so we can actually carry on with the project. I do actually quite want to get this finished. There is every cloud has a silver lining, as they say. What it does mean is I can do some experiments on this board. It doesn't matter how destructive I am with it now. I don't have to be careful with this board. It's dead. What I'm going to do is I'm going to find out how easy or how difficult it's going to actually be to remove the joystick from it, because it looks like it's just soldered on. Excuse me. There and there, and if I could take that out, and obviously I'll get rid of that LED because we're not going to be using this thing as a torch any time ever again. So on the original and the actual one, I'll be removing them. I'll also be removing the AV connector there, which does pose a little bit of a problem, and it's one reason why I'm not that disheartened about this, because it means I can actually figure this out, and it doesn't matter if I'm a little bit destructive. Essentially how this works is when you switch it on without the AV connector plugged in, it means that when you press the joystick port, the joystick forwards or down like that, it makes the LED at the end there illuminate, because this thing can be used as a torch. Like I said, the actual intention of this is you have it on the key ring, and as well as being a games console, like I said, you can also use it as a little torch to find your key and things like that. So when I remove that from there, it's going to think that this is a torch and operating its torch mode. When you push the AV cable in there like that, it must activate a switch inside the actual connector which says, no, I am not a torch anymore, I'm a games console. So because I can be destructive with this thing, I can actually figure out and not have to worry how that actual switching works, because obviously I'll have to disable that on the board and actually probably solder a little link between where them two switch contacts are, so this thing always thinks, yes, I'm a games console, and no, I'm not a torch. So like I said, every cloud has a silver lining. I can now do some more experimentation on this. It doesn't matter, you know, testing continuity and things. I can use a 12-volt car battery in a headlight if I want now. I mean, this thing's already dead, but it does mean, like I say, I can use this for just finding out some of the things I need to know before I get the new one, and I can actually then strip the bits off the new one and actually get it mounted straight up. And we'll get it mounted straight up in the actual new console for it, the new box. Anyway, that's basically it. I just wanted to make a little video to say that I've been a dozy Burke and rookie mistake, and I've fried the board. But I'd say all's not to lost. There should be another video coming on this as soon as I get the new controller in. So hope you enjoyed that little update on the project. Thanks for watching, and goodbye.